Oh boy. Now what? Well, if you see the screen, you'll see what I'm going to be talking about. UHD Forth. Stands for ultra high definition, 3840 by 2160 pixels. And that is my current version of Forth. And I have a lot of fun with it. Uh-oh. Excuse me, I've lost it. All right, it should be back now. Forth is a problem-oriented language. Now, one of the problems that Forth addresses is Forth itself. And UHD Forth is one of the first problems that I have to address. Now, in the course of addressing that, I have to define a character set. And this is the first part of it. 0 through 9 are the decimal characters. A through F are the hex characters. And this version of Forth does not have words separated by spaces. It has words separated by a stopper character. So a decimal number has a stopper set at 9. And if you have the word 6A, it's separated into 6 and A, because A cannot be part of a decimal number. But it tries to extract whatever part of the word is appropriate. In hex, the word 6A is the number 6A. Now, the reason I've done this is to make it more readable and more compact. You can eliminate a lot of spaces which aren't really performing any function. Here's the rest of the alphabet, G through Z. So when you're searching a word, your stopper is Z. And if you have the hex word 6AX, it is parsed into 6A and X. Again, the concealed space. Now there's another set of numbers, 0 through F, which are superscripts. And these superscripts are intended to represent registers. The 16 x36 registers. Again, this is an attempt to make the source code a little prettier. Finally, there are some special characters: dot, minus, plus, semicolon, subscript 1, fetch, store, times, divide, subscript 2, subscript 4, and tick. Of these characters are superior to the stopper Z, so that you can separate, again, break words into pieces. AB1, for example, is AB space 1. Regardless of whether AB is hex or whether AB is a word or whatever. So you've got these kind of conventions. X fetch is parsed into X space fetch. 1 plus is parsed into 1 space plus. So you get the advantage of compact notation, readable mnemonics, and excuse me. And there are a couple of special cases. This doesn't fit into the same paradigm. It requires an extra line of code. Superscript 6 pull is the same as number 6 pull, which is the same as number 6 space pull. So pull takes a number as its argument, and it is saying pull the number from the 4th stack into register 6. Also, there's a case where you have a number with a superscript following it. 100 superscript 1 moves 100 to register 1. In other words, 100 all by itself would go on the stack. 100 with a superscript will go into a register. This makes it easy and readable to load registers. I do a lot of assembler in UHD Forth. Here's an example. This is echoing back to color Forth, of course. Red whore is defining a word. The word is ABF32, and it's terminated with a semicolon. The semicolon is red. The semicolon is white. So when you're compiling whore, it will be executed. And when it is executed, it will put down a 3C, return from subroutine. ABF3 is a hex number. The subscript 2 says compile it as a 2-byte instruction. Put it into the, compile it into the dictionary as a 2-byte instruction. The F3 is the code for repeat, and the AB is the code for write register 0 to the address in register 7. It's a string operation. The fact that ABF3 is green means that when you execute whore, it will compile the ABF3 into your current dictionary, into your current word. Here's a case where I'm using for. It's the word clear. The first instruction is BF1, which is a 1-byte instruction. It fetches the next word into register 7, in this case, the low order 3 bits of F. The image is a 4-byte address. And it's the start of my graphic image. B91 loads the next word into register 1, the low order 3 bits of 9. And the word it's loading is NX, the number of X pixels, which is 3840. The number of Y pixels, 2160, product of, compiled as a 4-bit number. C031 is a 2-byte instruction. 31 is an exclusive OR, and C0 says register 0 with itself. So this puts a 0 in register 0. And then HOR compiles the previous instruction, semicolon marks the end. And the net effect of this is that clear will store 8 million pixels of 0 into the image. It clears the image very efficiently, because HOR is a string operator, and I presume that's the fastest way of moving data, although I've not actually timed it. But that's a small 4th word. There are lots of them. And this is part of the problem-oriented language dedicated to making pretty images on a UHD display. The number of registers, which I won't go into. But here's the character 0. And you see it being drawn by using the HOR instruction. Here it is again. This is using a Bresenham circle drawing algorithm, stretched vertically to produce the O. Here's another character, C. And it illustrates the fact that the 8 segments of a circle can be masked off to provide various circular arcs. I find these characters rather pretty. You've seen the full character set, although not in this excruciating detail. And you see here the 8-fold symmetry in drawing the circle. It's very efficient. In fact, it's more efficient than actually having a bitmapped mask representing the O, because you don't have to scan the entire bitmap. You can just draw the pixels where they're needed. Here's another example of the horizontal fill-in word pour, drawing a triangle in this case. You can see it draws it fairly quickly. It's actually, I'm displaying this at 60 Hertz. And each line, you're getting 60 lines per second. It's a high resolution image. It takes a while to draw, but it doesn't take this long because I have deliberately slowed it down. So here we have a star. It's drawn with 3 triangles, 3 isosceles triangles, and it uses the ability to erase part of the image if that makes it an easy way to draw. Here's a flag. It's got 50 stars in it. And it is an accurate rendition of the official US flag. It's got the right aspect ratio, the right size field, the right size stars, and the Old Glory red and Old Glory blue colors. At the very bottom of the screen, you see my cheat. This is the reminders to me of what I want to do and the order I want to do it. Here's another example of large characters. This, you may notice, is the current time. And you see how the characters are built up of circular arcs. The 9 is an oblate spheroid. The 0 is a prolate spheroid. The 9's got some curls and the 5 has got a jag in it, which I haven't been able to fix. Oh. '85 load. Oh, yes. And there's the classic "Don't Panic," which is maybe an admonition about Win32 Forth. Strikes me as extraordinarily complex. Kitchen sink, everything you ever wanted is included in it. Whereas in UHD Forth, the only things that are included are that which is necessary to write a little application. Let's go back to and draw this star again. And then just a little pizzazz. There's a starburst. That does it for me. Any questions?
Yeah, one thing I just made a comment in the chat that your demo of doing a flag with, I guess it was the Novix chip, sort of bare bone stuff at one of Larry Fordsley's Rochester conferences. Just absolutely. I mean, it's indelible. And you had this you had micro switches soldered to a wire velcro to your knee, which you were putting in the byte, you know, and you commented that there was no buffering between the chip and the display, and that the hard part was drawing the stars. So I mean, that was, you know, wow.
Yeah, those were the days. I have recently learned how to draw triangles. Now, this star is drawn with isosceles triangles, which are pretty easy. But now I've got the code for a general purpose triangle. I've been planning on doing this for years. I finally got around to it. It's not quite working, but next year I'll show you how to use triangles.
Does anyone here at Stanford have any questions?